Today on Why Do We Need to Know This, we'll learn about powers of 10. We'll also learn how to multiply and divide large numbers using powers of 10. And we'll see that this knowledge can help us wash a dog, run for president, and even count $1 million.
How many should we get?
I don't know.
Hey, April. Hey, Marcos. What's up?
What's up, Addisina? We're ordering cookies for a bake sale.
Yeah, we're raising money for a charity.
The cookies come in packs of 25, and we're ordering 100 cookies. And done.
I don't think you ordered 100 cookies. It looks like you ordered 100 boxes, which have 25 cookies each.
Marcos, how many total cookies did you actually order?
Since it's 100 boxes of 25, we could do 25 times 100 to figure it out.
I can't multiply 3-digit numbers by 2-digit numbers in my head.
I can. You accidentally ordered 2,500 cookies.
How did you do that? Are you a human calculator?
Nope. I just know about powers of 10. They can help you multiply and divide large numbers.
But we already know how to use an area model and a calculator. Why do we need to know this?
Powers of 10 can help us wash a dog, run for president, and even count $1 million. Let's explore. Have you ever seen a movie where one of the actors has $1 million in a suitcase? Well, with powers of 10, we can see what that really looks like. Check this out. Here we have $10. Now, if we multiply that by 10, how much would we have?
10 times 10 is 100, so we would have $100.
Yes. Let's keep multiplying by 10 until we get to 1 million.
If this pile has 100 and we multiply by 10 again, then the next pile will have 1,000. We can represent that as 10 times 10 times 10.
The next pile has 10 times as much, so $10,000, which we can represent as 10 times 10 times 10 times 10.
And this pile has 10 times as much as the previous one, so $100,000, which can be represented as 10 times 10 times 10 times 10 times 10.
And finally, $1 million! Whoa! This is 10 times as much. $1 million can be represented as 10 times 10 times 10 times 10 times 10 times 10.
Yes! You can see that each pile has 10 times more than the next one. When working with large numbers, it's sometimes more convenient to represent these numbers in another form, called powers of 10. This chart shows 3 different ways to write each number. There's number form, like 1,000. There's expanded form, which is 10 times 10 times 10. And now we have another way to show this number, using powers of 10. So 1,000 is the same as 10 times 10 times 10, which is the same as 10 to the power of 3.
I get it. It's 10 to the power of 3 because you are multiplying by 10 3 times.
Exactly. What patterns do you notice in this table?
The power of 10 shows us how many times to multiply by 10.
Yes. Anything else?
How many zeros there are in the number is the same as the number in the power of 10.
Great observation. Notice that 10 to the first power has 1 0, 10 to the second power has 2 zeros, and so on.
Another pattern is that each time you multiply by 10, the digits shift 1 position to the left.
Ooh, let's see that. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1 million. The digits shift 1 place value to the left each time.
Excellent. That knowledge will help us solve problems.
What are we gonna do with all this money?
We're gonna donate it to charity.
All of it?
How about, like, almost all of it?
All of it! How could you even think that? It's all going to a charity called Addisina's Foundation for Better Vacation.
What?
Just kidding. The money's fake.
What?
All of it?
Next, let's see how powers of 10 can help us multiply large numbers. And welcome to Genius Air, the world's smartest airline.
Where the planes are a bit small.
Each of our planes have 162 seats, and we have 10 planes. How many seats is that?
So to figure this out, we can do 10 times 162.
Yep. Previously, we learned that when we multiply by 10, all the digits shift one place value to the left. They become 10 times greater.
So if we start with 162 and shift all the digits one place value to the left, the 1 is now in the thousands place, the 6 is in the hundreds place, and the 2 is in the tens place. Since we have no 1s anymore, we put a 0 there.
So this means 10 times 162 is 1,620. Our airline has 1,620 total seats.
Great. And remember that 10 times 162 is the same as 10 to the power of 1 times 162. Now, let's say each of those 1,620 passengers pays $100 for their flight. How much is that in total?
So we need to solve 1,620 times 100. We know how to multiply by 10 now. But what about 100?
100 is the same as 10 times 10. So when we multiply by 100, we're actually multiplying by 10 twice.
So if we multiply by 10 twice, we must shift the digits 2 place values.
Since we have no 10s or 1s, we put zeros there.
1,620 times 100 equals 162,000.
Now climb on board. It'll be a tight squeeze, but what do you expect for $100? Next, let's see how powers of 10 can help us multiply things that aren't whole numbers. And get scruffy here, washed.
Is the bucket to fill the tub?
Yes, one full bucket holds 6.85 liters of water. How much water would 10 full buckets hold?
We can figure that out by multiplying 10 times 6.85.
Will the same method still work, even for decimals?
I think so. When you shift digits one place value to the left, they get 10 times larger. Decimals have place value too, so we can use the same strategy.
So 6.85 multiplied by 10 is 68.5. We just shifted all the digits one place value to the left.
Great. Since the digits can't move like that on paper, we can also show the same thing by moving the decimal point like this. The result is the same. Each digit moved one place value to the left.
It's going to take a lot more than 10 trips to fill this tub.
You ready for your bath?
What if we use the larger bucket that is 9.4 liters and fill it 100 times? How much water would that be?
Too much.
You're probably right.
But we can solve that by multiplying 100 times 9.4. 100 is 10 to the power of 2, so the digits shift 2 place values.
And since we end up with no 1s, we add a 0 there.
So the answer is 940 liters of water. And this is the same answer you would get by multiplying 10 to the power of 2 times 9.4.
Well done. And since on paper you can't move the digits that way, you can just shift the decimal point to the right 2 place values. Now comes the hard part. Getting scruffy ready for a bath. Next, let's see how powers of 10 can help us divide. April and Marcos are both running for school president. Tell us about what you're going to do.
When I'm president, every student will get free ice cream every day.
When I'm president, I'll ban homework.
Oh yeah? Well, everyone will also get a free dog.
I'll get them 2 dogs.
Okay, that's enough. Did you get those stickers made?
Yes, I ordered 800 April for President stickers. 10 of my friends will pass them out for me. If I want to give an equal amount to each, how many should I give to each friend?
You can figure that out by solving 800 divided by 10.
Can we use powers of 10 for division too?
Yes, when you divide by 10, you're making the number 10 times smaller. So you move all the digits one place value to the right.
That makes sense, since division is the opposite of multiplication.
So, to solve 800 divided by 10, we just move all the digits one place value to the right, which makes the answer 80.0, which is the same as 80 stickers.
That's right. Marcos, how are you going to campaign?
Well, instead of stickers, I have a different strategy to get elected. I'm giving away 250 bowls of ice cream. I'll split it equally between 100 students. How much should I give each student?
To find out, you can solve 250 divided by 100.
Since we are dividing by 100, we'll move the digits 2 place values to the right. That means each student gets 2.5 bowls of ice cream. They are definitely gonna vote for me.
Excellent. And just like before, you can't move the digits that way on paper. So you can just shift the decimal point to the left 2 place values. Oh, April, did you know that there's a typo on these stickers? They say April 4 president.
That's because I'm 4 times the better candidate.
Oh, and Marcos, that ice cream has been on the table for a very long time.
Oops. I guess it's ice cream soup for everyone. Vote for me.
Now that you understand powers of 10, you should know how I solved your cookie problem in my head.
We got this. Since I ordered 100 boxes of 25 cookies, that is 100 times 25.
So to solve it, we just move the digits to the left 2 place values. That makes 2,500 cookies.
And that's the same answer as solving 10 to the power of 2 times 25.
That's right. Now, let's review.
Today, we learned about powers of 10.
We also learned how to easily multiply and divide large numbers using powers of 10.
And how this knowledge helped us wash a dog, run for president, and even count $1 million.
And now you know why you need to know this. I'm Adesina.
I'm April.
I'm Marcos.
And remember, until next time,
Always question, always wonder.